Welcome TAS friends, this is Mr. Brocklehurst and I'm here to walk us through and introduce our next simple machine set, the wheel and axle. Let's get started. Have you ever seen an old-fashioned water well? You know, the kind with a crank handle and a bucket on a rope? Well, guess what? That crank is more than just a handle. It's a simple machine called a wheel and axle. A wheel and axle is made up of two parts. A wheel, which is easy to turn, and an axle, which is usually a smaller rod that turns with it. When you turn the big wheel or crank, the smaller axle spins. The rope wraps around the axle, and ta-da! Up comes the bucket of water. Now, let's imagine trying to lift the bucket straight up by pulling the rope. That would take a lot of force. But when you use the wheel and axle, you're spreading that effort out over a greater distance. You're turning the wheel in a circle, and that motion gives you something powerful, mechanical advantage. The bigger the wheel compared to the axle, the more mechanical advantage you get. It's like a trade. Your hand moves a further distance every turn, but you lift it using less effort force. Let's break that down. If the wheel is 4 times bigger than the axle, you only need 1/4 the force to lift the bucket. That's the magic of mechanical advantage. So instead of struggling to lift a heavy bucket full of water, you're using the wheel and axle to do the same job with less force. Okay, now let's look at a third situation. In the third situation, you have increased the size of the axle this time. How would this affect lifting the bucket? First, let's consider the rope winding up on the axle. To raise the bucket with a larger axle, each turn should wind up more rope since the axle has a larger circumference. If each turn lifts more rope, would you need to turn the handle fewer or more times? Pause the video now to consider this question. Hopefully, after thinking this through, you've come to the conclusion that fewer turns are needed to wind up the rope around a bigger axle. Super challenge question. If you need fewer turns to wind up the bucket, how does that affect the effort force you need to lift the bucket? Pause the video now to consider this question. Remember, with simple machines, that there is always a trade-off between effort force and effort distance. If you don't need as many turns of the wheel, you must make up for that with more effort force. More effort force needed means that your mechanical advantage has decreased as well. Thank you for your time today. Keep asking questions, keep exploring, and remember, when life gives you a heavy bucket, use a wheel and axle.